Yeah, well, a very good day. It's hyperchemist. Now still under thermochemistry, we're going to look at enthalpy of hydration. In our previous lesson, we looked at lattice energy, and I told you we're going to look at lattice energy, hydration, and then we connect them to enthalpy of solution, and then maybe you can always compare the solubilities of the ionic salts. Yeah. So now here we are looking at enthalpy of hydration, and for enthalpy of hydration to come into play, we always have a solid lattice. For example, sodium chloride is a solid lattice. This solid lattice, when it dissolves in water or when it is dissolved in water, because hydration, we are basically oriented talking about the dissolution of the ionic solids in water. So when this lattice is dissolved in water, it will separate these ions. So we shall have sodium ion, gas, and chloride ion, gas. As we saw before, that when a crystal lattice splits into its constituent gaseous ions, that is the lattice energy that is involved there. So we have lattice energy, DH lattice. Then these gaseous ions, it is these gaseous ions that interact with water molecules. And then we are going to find out that the positive gaseous ions are attracted to the negative end of water molecules, and the negative gaseous ions are attracted to the positive end of the water molecules. And the energy that is going to be released here in forming a solution is what we call enthalpy of hydration. So we have enthalpy of hydration, and this is sodium ion now aqueous, and also a chloride ion aqueous. So this is enthalpy of hydration. So it is the solid, ionic solid first. When dissolved in water, it is separated into the ions, and that energy is called the lattice dissociation enthalpy. One can call it lattice dissociation enthalpy or enthalpy of lattice. Sorry. Or one can call it lattice energy. But basically, since this is dissociating, we shall have lattice dissociation enthalpy. And when these ions interact with the water molecules to form a solution, we are going to have enthalpy of hydration or enthalpy of solvation. I'm going to call it solvation. So now here, this one brings us into a deduction that enthalpy of hydration is the heat given out the heat given out when 1 mole of gaseous ions is completely surrounded by water molecules to form an infinitely dilute solution. Dilute solution. So one can add with no change in pH, or one can leave it. I want you to note that enthalpy of hydration is an exothermic reaction. Yeah. Is exothermic. And being exothermic, it implies that it is always having negative values. So it is always a negative value. It is always a negative value. That is what we should know. But I want you to also remember from a previous lesson that lattice energy for it, these notes are very important in the future there. Lattice energy can be positive or negative. It is positive when, for example, sodium chloride is dissociating into gaseous ions. So that is what we call the lattice dissociation enthalpy. And this is what we shall always use when we are calculating enthalpy of solution or when we are deducing solubility. So we always use lattice energy as a positive value, but it is only negative when those gaseous ions are combining to form a crystal lattice. So after you've noted this, then that was some clarification in case one was confused about that too. But then the factors that affect these two are the same. The factors that affect hydration energy are the same factors that affect lattice energy, only that maybe the description can be a bit different. So let's look at the factors that affect enthalpy of hydration. One, here we shall have ionic radius as one factor, and another factor shall have ionic charge. Shall look at the aspect of polarizing power. Yeah. So here we are going to find out that the smaller the ionic radius, the smaller the ionic radius, the higher the higher the hydration energy. Simply because the forces of attraction between ions, the forces of attraction between ions for water molecules are strong. That is how we just simply can explain it. But for the case of ionic charge, here, we need a higher ionic charge for hydration energy to be high. So the higher the ionic charge, the higher the hydration energy. The higher the hydration energy. Simply because the forces of attraction for water molecules the force of attraction for water molecules as strong. So I'm going to give you a sample question and then we see. A sample question is, which of the following metal ions sodium ion, aluminum ion, magnesium ion, is likely to have the highest hydration energy? Give a reason for your answer. So here, I think you can see that aluminum has the highest ionic charge, and being the highest ionic charge, it has the highest ionic charge, yes. And when the ionic charge is high, then the ionic radius is small. And the ions with the small ionic radius, they have high charge density and high polarizing power, meaning that the ion is easily hydrated and therefore strongly attracts very many water molecules compared to others, giving off high or the highest amount of hydration energy. So you would say aluminum ion. The answer would be aluminum ion has the highest hydration energy simply because it has the highest ionic charge. It has the highest ionic charge, smallest ionic radius, highest charge density, and highest polarizing power. Polarizing power. So the ion is easily hydrated. The ion is easily hydrated and therefore attracts very many water molecules, hence giving off the highest amount of energy. So basically, this is what one would be writing. You look at the ionic charge and then you compare. So here, still under hydration energy, we are going to look at some of the calculations. We're going to look at some of the calculations, and here is a table showing ions and their enthalpy of hydration. So here we're going to be having ion, and then here I'm going to be having enthalpy of hydration. we shall have potassium ion, we shall have calcium ion, we shall have fluoride ion, we shall have chloride ion. Here enthalpy we have 305. Here we shall have 1545. Here we shall have 530. And then here we shall have 394. This is in kilojoules per mole. So the first question goes that the first question goes as state why at A. Okay, state whether the values of enthalpies of hydration above would be positive or negative. Of course, we shall give a reason. Now, of course, I told you before that all values of enthalpy of hydration are negative. So the values should be negative. That is the answer. The values should be negative. But then we want to see the reason why. The reason is because hydration of these ions, yeah, you say hydration of ions involves attraction of water molecules, releasing a lot of heat. Releasing a lot of heat. Attraction of water molecules, releasing a lot of heat. But then we want to also explain the differences in the enthalpies of some of the ions. Yeah, we want to explain the differences. What can you talk about the difference of, before we go to any calculation? What do you compare? What do you talk about the differences of these? Why is calcium ion having a higher enthalpy of hydration while potassium ion is having a lower enthalpy of hydration? The reason is simple. It's because potassium has a larger ionic radius and smaller ionic charge. Having small ionic charge, it means that it has a lower charge density, thus a lower polarizing power, and thus it has lower attraction of the water molecules than the calcium ion, because the calcium ion is having a smaller ionic radius and a higher ionic charge, giving it a higher charge density and higher polarizing power, meaning it strongly attracts water molecules. So the calcium ion is easily hydrated compared to the potassium ion. So when you're giving your explanation, please, you can base on either calcium, you base on, then you later correlate to potassium. So one would say potassium ion has a higher ionic radius compared to calcium ion, which has a smaller ionic radius. Thus, potassium ion has a lower charge density and lower polarizing power. Thus, it poorly attracts the water molecule, giving off a lower amount of hydration energy compared to calcium. Okay? But then when you're talking about these two, if you're relating about fluorine and fluoride ion and the chloride ion, if you're relating those two, you'll be talking about now the fluoride ion having a smaller ionic radius than the chloride ion. Yeah. Thus, the fluoride ion has a higher attraction for the water molecules, giving off a higher amount of heat. Now, the issue here, we want to calculate the enthalpy of hydration of calcium fluoride. Calculate the enthalpy of hydration of 1 calcium fluoride to potassium chloride. So to calculate for calcium fluoride, I'm going to be very brief here because it is just a two-step thing. So to calculate for calcium fluoride, first dissociate calcium fluoride. You can see that calcium fluoride gives us calcium ions and 2 fluoride ions. Now, when you're looking for enthalpy of hydration, this is it is the summation of the independent enthalpies of these ions because we are given individual enthalpies. So we add the enthalpy of hydration of calcium ion plus, since we are giving 2 fluoride ions, we shall have twice enthalpy of hydration of the fluoride ion. So it would mean that here, the answer, let me complete it from here, it will be enthalpy of hydration of calcium. We are having 1545. But remember, these values must be used as negative, though they were given as positive. So it must be negative 1545 plus twice times the one of fluoride, negative 530. The summation of these gives negative 2605 kilojoules per mole, and that is the enthalpy of hydration. So for any viewer, I want you to get for potassium chloride. Get for potassium chloride. Don't forget that any value of enthalpy of hydration is used as a positive value, or rather negative value, even though it was given as a negative. So now, from here, I'm going to be looking at how to connect these to enthalpy of solution. We're going to look at how to connect them to enthalpy of solution. See you there.